So it is 3 minus 0.6990. The value comes to finally 2.3010. This is the answer for this one. So let us see once again. So they are given directly, the hydronium ion concentration of an acid is given as 5 into 10 to the power of minus 3 molar solution. So we have taken the formula for pH, which is minus of log H plus we have, and then that is equal to, we are substituting in the place of H plus the value of 5 10 to the power of minus 3 here, and then this is minus of log 5 we have, and then this is minus sign here, minus of minus log 10 to the power of minus 3. So this we brought here now. So with this minus sign as it is there now. So this minus and minus 3 log 10 we have. So minus of minus 3 log 10 minus this we have taken here now. So minus log 5. So this is equal to 3 here because minus of minus plus 3 we have. So 3 minus log 5. And for this value log 5, you need to see the tables book. In the tables book, the value of log 5 will be given as 0.6990. Therefore, it is 3 here minus 0.6990, which comes to 2.3010. This is a first case wherein directly when hydronium ion concentration is given to us. Now coming towards second category, means whenever the concentration of acid is given there. This category we will take up next. Right, now we have seen the first category wherein concentration of H plus is given directly. Now we are going to the second case of the acids here, when concentration of acid is given. Here when concentration of acid is given means, first step is we need to calculate what is the concentration of hydronium ion in the given acid first. That's to say, let us take, again we have 2 or 3 cases coming in this case now. So here again, that is to say, so for example, say HCl is given to us in some cases. Say concentration of HCl is given, say as 0.02 molar, and let us suppose that in some other case concentration of sulfuric acid is given, say it is as 0.02 molar for us now. So concentrations of acid is same in both the cases. First step lies that we need to calculate what is the concentration of H plus of HCl and what is the concentration of H plus of sulfuric acid. Because first one is coming under monobasic acid, second is a dibasic acid for us now. So therefore for all acids, the concentration of H plus means H plus in the case of acids will be equal to normality of the acid. It can be taken, that is normality. Suppose if at all molarity is given as in these cases here now, this molarity, that is molarity is given for us here, should be multiplied by the number of replaceable H plus ions which are present here. Means in this case into 1 we should do, it is into 2 for us now. There is nothing but molarity into basicity of the acids we have. Then from this you are going to get the hydrogen ion concentration. From there finally we can calculate the pH value of the acids. Now we will solve these 2 examples now. So here let us take first of all HCl. Now in HCl acid, they are given molarity as 0.02, and for HCl the basicity is equal to 1. Therefore this implies hydrogen ion concentration for HCl will be equal to 0.02 into 1 only, because basicity of HCl is 1 for us, which is equal to 0.02 or 2 into 10 to the power of minus 2 for us now. So many molar of H plus ion concentration we have. Now once you found out the concentration of H plus of this acid here, then directly we can substitute in the fundamental formula of pH. That is, pH is equal to minus of log H plus, which is equal to minus of log. Now here we found out already the value of hydrogen ion concentration, and we are substituting here, which is minus of log 2 into 10 to the power of minus 2. This calculation we are doing on the other side here, that is to say continuation of that. So which is pH is given as, there what we have is minus of log 2 into 10 to the power of minus 2, which is equal to minus log 2, this is minus log 2 we have, and minus of log 10 to the power of minus 2. This is a minus, this again which is equal to this minus 2 I am writing here, minus 2 log 10 to the power or else this other way is we can write as 2 minus log 2, which is equal to 2 minus 0.3010, which is equal to 1.699. So this is the answer for this one now. So when concentration of acid is given, we have taken the first example where the number of protons given by acid is equal to 1. Now we are going to take up the second example where the concentration of sulfuric acid is given as 0.02 for us. So in the case of sulfuric acid, the concentration of H plus and the concentration of acid are not equal because H2SO4 comes under a dibasic acid for us. So now we will solve this particular problem now. So here also the step will be seen. The first thing we need to calculate the hydrogen ion concentration from the acid. Then finally we have to calculate the pH value of the acid. So here applying this particular formula in this case, first we have to find out the hydrogen ion concentration of sulfuric acid, which is equal to molarity into basicity. Molarity is given as 0.02 molarity we have, and basicity of the acid is 2 because dibasic acid we have taken there 2, which is equal to 0.04 we have. Now this is the concentration of H plus for dibasic acid. Similarly, if at all they give us a tribasic like phosphoric acid, it should be done into 3 for us now. Like this, any acid, if at all the concentrations of the acids are given, that is, if they are giving us molarities of the acids, then we need to multiply the molarity with the concerned basicity of the acid. Suppose if at all they are giving directly the normality, then we need not multiply that one. Directly normality can be used as the concentration of H plus for us. Now coming toward the solution part of this particular problem here. Now second example we are seeing here, that is to say when basicity is differently given other than 1, that is sulfuric acid. So sulfuric acid molarity is given as 0.02 here. So from this, first of all we are calculating the hydrogen ion concentration using this formula. Hydrogen ion concentration is given by molarity into basicity, that is the number of replaceable H plus ions of the acid for us. So H plus, that is the molarity of the acid here. This 2 is nothing but the basicity of the sulfuric acid into 2, which is equal to 0.04 we have. Now pH is equal to, applying the fundamental formula, minus of log H plus, which is equal to minus of log, we can write this value as 4 into 10 to the power of minus 2. That is 0.04 is 4 into 10 to the power of minus 2. Later on you can expand this one. So which is finally equal to, that is 4 minus, that is equal to minus log 4 and the same minus sign here, minus log 10 to the power of minus 2, which is equal to 2 minus log 4. Again for this 4 we have to see the tables book, there we can get the value there, which is 2 minus 0.6020. So because we know the log 2 is 0.3010, log 4 will be 2 into that value, which is equal to 0.6020. So 2 minus 0.6020 value we need to take, which is equal to 2 here minus 0.6020 for us, which is 0.893 here. Therefore the value comes to 1.398. This is the answer for that. So once again sulfuric acid is given, molarity is 0.02, we have multiplied by 2 to get the hydrogen ion concentration because 2 is its basicity. Then we are substituting the fundamental formula, which is pH is equal to minus of log H plus. H plus, this value we have taken here. We have written this value in the form of 4 into 10 to the power of minus 2. Later on expanded the logarithmic form. Finally we got 2 minus log 4, which is equal to, log 4 value is 0.6020 we have, which is equal to finally 1.398. So with this we have seen the second category wherein the calculation of the pH of the problem when the concentration of acid is given for us. Two different cases we have seen wherein basicity is 1 and basicity is 2 for us. Now we have to take up the third category of this one, when certain amount of acid, means certain weight of acid will be given as well as the volume of solution also will be given to us. From these two, first of all we have to calculate the normality of the acid, Then finally we have to apply the same fundamental formula and then we can proceed further. Now, okay, so third category we are seeing now. Say for example, the problem may be like this. Say 0.63 grams of HNO3 is dissolved in 100 ml water. What is the pH value of that solution for us now? Now here in this case, weight of solute, that is HNO3, is given for us, as well as the volume of solution is also given to us. So again we need to calculate what is the hydrogen ion concentration for this case, and we need to apply the fundamental formula there. So to calculate hydrogen ion concentration, we have seen that hydrogen ion concentration for acids is nothing but equal to normality.